Okay, good morning, everyone. Welcome to our Hope for Air Quality Showcase for Business Opportunities with Helsinki Air Quality Data hybrid webinar. And well, I hope you hear me and see me. Today, we have a host of speakers. About half of them are going to be speaking from the distance, from the safety of their office or their home, and then about three speakers, including me, three and me, are going to be here present in a so-called studio at Marja 01 in Helsinki. Well, you see the program of the day. So my role is here. I'm the project manager of this HOPE project, so Healthy Outdoor Premises for Everyone, work for City of Helsinki Economic Development. I will not present the HOPE project as such. Some of the speakers will touch upon certain elements of it, but the point here is rather to sort of show you the data that we have in a project and sort of present it as open data. It's available for anyone to use. And then we have some kind of use cases. Now basically, if I go through briefly the program, so first, Professor Tuukka Petäjä will have a bit of an opening speech after me. Then Andrew Ribeiro-Hargrave from University of Helsinki will present the MegaSense data platform, which is the platform that offers some of our air quality data. Then we have Lasse Johansson from Finnish Institute of Meteorology, and he'll present the end-user model and the open APIs of the FMI. Then we have Age Palm from University of Helsinki as well, of Digital Geography Lab, presenting the green paths and open source route planner. And then we have three small cases of the companies. And these are companies who were, who were successful in our innovation competition, which we ran from last March until August. They're going to be giving us small presentations of what they're doing with our data, how they're using it, use case presentations. And then in the end, we have kind of, as we say, sugar at the bottom. We have Pekka Niskasaari from Virium, and he'll present or introduce the second round of the HOPE Project's innovation competition, which is about to kick off in very soon, next week, November. So I guess now I switch over to Professor Tuukka Petäjä, just a moment. And here he is. Tuukka, please.
Thank you, Jussi, and good morning, everyone. So my name is Tuukka Petäjä from University of Helsinki, and I'm actually very happy to be here to start the meeting. I will, Jussi, I will not show anything. I will just reflect on few of the key things that I see that we have today in the meeting, and I'll let then the speakers introduce the topic in more detail. I think the key issue what we have is the capacity in Helsinki really to connect high quality observations of air quality, what we do together with University of Helsinki and Finnish Met Institute and HSY, the Finnish and City of Helsinki. And Helsinki as such offers very unique possibility to then combine comprehensive observations, research grade knowledge on atmosphere, and then high quality modeling, high resolution modeling, and also the collaboration within HOPE project has enabled very close working together with the citizens and the City of Helsinki as well. So we are combining all of these expertise, and we are collecting a wealth of data which provides us a thorough understanding what happens in the city in terms of the atmosphere and how the citizens influence and the activities in the city influence the air quality and the environment. And this offers, of course, many possibilities then to improve the processes in the city and also to improve the quality of life of the citizens. And our main thought behind actually is to provide high quality data through the open data sources, which is then can be utilized in, for example, developing different applications that help. For example, the green path that is presented today, that's a very excellent example of this potential of the data. So that's briefly how I see what are important today to discuss on the possibilities and find new connections. So we are here to interact with all of you. So let's hear then from the presenters, and welcome from my side. Thank you.
Okay, thank you, Tuukka. And I forgot to say that all the speakers have about 10 minutes time, so please stick to that. That's always important. But hey, now let's give the stage to Mr. Andrew Hargrave. And just a moment to put you on here. Oh, you need to roll that. Yeah. Well, please.
Good morning to you. Thank you for giving me the opportunity to present the slides. So I'll briefly talk for 10 minutes about the MegaSense data platform provided by the University of Helsinki. And we created the MegaSense data platform to collect data from low-cost air quality monitoring. We collect data from all sorts of areas, but in this project, the requirement is for low-cost air quality monitoring for 9 measurement campaigns in 3 urban districts in Helsinki. We give these devices to 100 citizens, and they carry the devices for about 3 months, and they measure their own exposure to air quality. And throughout the whole project, we do this 3 times in each district. So the University of Helsinki, what we've did is we've developed this portable mobile air quality sensor. You see a picture of someone holding this. And the purpose of this being portable is that you attach it to your backpack or your pram or your dog leash, whatever you want to. This small low-cost device measures particulate matter, ozone, carbon monoxide, nitrogen dioxide temperature, movement and light, and has a GPS, so it's tethered to your smartphone, so we know exactly where the user is carrying this device. Now, the device itself is what the end user sees, but in reality, the information goes back to the MegaSense data platform. And here we see 2 diagrams. One is we developed a data platform for research, and this actually covers multiple projects, not only HOPE, but it also covers other City of Helsinki projects. In the left corner, we see the app that we've created. It goes through APIs to distributed storage. We do analytics such as calibration on that, and what the user gets back are their exposure profiles, for instance, PM per user. We are evolving this into a larger architecture because we can move this data platform to wherever we want to provide real-time personal measurements again for air quality. Now, so we have both the device and the platforms. We need to test this, and we've tested these in 3 districts as per the requirement: in Jätkäsaari, port area, Välilä, sort of densely built area with urban street canyons, and Päkkilä, suburban area with people using fireplaces for heating and saunas. When we tested these, we gave the devices, as you can see in the right picture here are people queuing up to get our devices. We had different data campaigns. In Jätkäsaari, we have 24 citizens carrying it. In Välilä, 22, and in Päkkilä last year, 40 citizens. They're carrying these devices, but we have no idea how they're going to use these devices and what they're measuring. When we look at the data from the MegaSense platform, we see that in Jätkäsaari, the idea of the low-cost devices, they're both indoor, measuring indoor air quality, and outdoor. So in Jätkäsaari, we have a higher measurement indoor. In Välilä, we have a high frequency of measurements outdoors and in the evening, and in Päkkilä, a mixture of both. So perhaps at between 3 and 16 people take these devices for evening walks. Now, note that these bacular measurements are pre-COVID-19. We can see this in the distances they carry the devices. So in Jätkäsaari, most people carry these devices less than 1 kilometer, and it's quite similar to Vallila. Whereas in Pakila, which was last November, pre-COVID, we see a mix, and we see people carrying the devices up to 6 kilometers as they take them for their walks. In this diagram, we don't know the directions they take them, but we can see that we have an extremely good spatial coverage. So we have Jätkäsaari covering the whole of Jätkäsaari, making their measurements. Vallila walking around these street canyons with a different type of morphology. And then in Pakila, we actually see a lot of people taking them in the forest and in the parks. So again, we see that pre-COVID, people are sort of going out more than in the sort of in today's date of people working from home. Now, one thing with these low-cost devices, we need to ensure that the data is accurate, so people are confident, and so we sort of measured these against the nearest reference station, the city reference station, and the results are fairly good. Remembering that half the results are taken indoors and outdoors, so is a difference. So indoors we have lower measurements than outdoors. The reference stations are all measuring outdoors. But what we see in Vallila, we see a sort of mean increase of our devices as people walk near the traffic than the reference devices. And then for, this is annoying that it changes itself. Then for the more information, we have sort of open the data with the venture with AIR, so you can access our data from that. And of course we have, for business users, we have a consortium working with Nokia who want to sort of take this work to the sort of bigger world and more international scale. So testing the MegaSense with a sort of Hope logic in other cities, such as City of Edinburgh and other cities we're talking to. And in general, the roll-up is that we produce the mobile devices for users. It's caught by the internet and by people having smartphones. We need to do analytics and open the APIs. So we need to improve the data with our calibration. But then the data goes back to the communities and developers for businesses wondering what can they do to add value to this data. So the MegaSense data platform really provides, it's not just a platform, it's an end-to-end solution so people can have happy and healthy journeys throughout the cities that they live in. For more information, then we have various social media connecting points. Thank you very much. Yeah.
All right, thank you. Good. So thank you, Andrew. We're very nicely on time as well. Oh, so I take this moment because I sort of forgot to mention a while ago that should you have any questions or comments to the speakers on a YouTube platform, there's a chat window where you can leave any comments or questions. We'll keep an eye on those and we try to answer those. And at least a while ago there were none yet. But please, any comments, questions can be left there. But if we just go on with the program, so to say, the next person speaking is going to be Mr. Lasse Johansson from Finnish Institute of Meteorology. He's going to be presenting the end-user model. And so, Lasse, the floor is yours, please.
All right. Good morning, everybody. So I will try to share my screen. Just a minute. And all right, I'm hoping that you are able to see my presentation.
We can see and hear you well. So go
okay.
ahead.
I will also hear myself speaking. Okay, not right now. So good that microphone is muted, so I can start the presentation. So the topic for my presentation is the end-user, the latest version of it that we are using in this HOPE project. And I will also show you a couple of examples on how to access the model data and what are the latest developments. So in this brief presentation, I cannot really explain how the model works in detail, but this is an outline of the modeling principle. So we are talking about a local scale dispersion model, and therefore we utilize or collect information on the local emission sources and collect meteorological data for the dispersion modeling. And one specialty of this Enfusion model is the utilization of measurement data. There is an built-in data fusion method in the model, so that based on the most recent measurements, the modeling adapts to the measurements so that a higher agreement between the model predictions and measurements can be achieved. And apart from the measurements and meteorological data, we are also utilizing some quite interesting real-time information sources. For example, in Helsinki, we have road weather stations and even some traffic congestion data included in the modeling. And our focus is indeed in the local scale, so here is some more artwork of the modeling output in Helsinki. All right, so here is a more detailed list of our information sources in the model. I guess the main thing here to be said is that our focus is not just in the modeling of Helsinki area. We are also doing modeling work outside of Finland, namely Delhi and in China, and also in the United Kingdom at the moment. And therefore, most of our information sources are actually global information sources. For example, we can tap into more than 6,000 measurement sites across the world to get that necessary measurement data for our modeling system. Right, I will move on now. So one of the main topics for this presentation is actually the APIs for people to utilize the measurement data. So this is an open source service, and the Enfusion modeling data is available at FMI's Open Data portal. And now I'm talking about a service that was first introduced in March 2018. And to avoid confusion in this new running a HOPE project, we have been developing a version 2.0, which I will address later on. But this operational system, you can access the model data with these instructions shown here. So basically, if anybody follows this link in this shown in this presentation, there you can get this kind of a XML response showing what is the recent modeling one available for you, and then you can use this information to access these download links, and then you are able to download somewhat large gridded data sets showing the modeled pollutant concentrations in Helsinki area. So with this data access, you are able to get the data for the Helsinki metropolitan area. So this is the only modeling area for now added in this FMI Open Data Access. In the future, it is possible that we will add more Finnish cities, such as Turku, Tampere, and cities like that. Okay, so if we take a look, what are these services that we know of that are utilizing this data? So first, there is this air quality map from the HSY. So you might have seen this service on those public transport displays. So this is one service that utilizes that FMI open data, as I mentioned previously. Then we had this nice collaboration with this Stara company that's responsible for the road maintenance actions, cleaning and dusting the roads, and they were utilizing these coarse particle modeling results with that open data portal. And then there is the new upcoming service for more averaged annual or perhaps monthly pollutant concentrations around the Helsinki area, but I will not steal anybody's thunder in that sense. So since this is a new service and it will be announced more properly later on. And now we can move on to this 2.0 development. So we've had the experience of providing the data for more than 2 years with this FMI open data access, and we have seen some things that we can definitely improve later on. For one, there is a somewhat notable production lag when we produce the model data sets and when the newest data sets are actually visible on those platforms that I mentioned for you. And we have also seen or got some feedback that the file sizes are actually quite significant, especially if any third-party application intends to archive it, and also with regards to the availability, we are only providing the latest modeling data set, and this means that if anybody would be interested on the air quality 1 week before, then that data is not yet available. And then, of course, we are only providing these modeled high-resolution pollutant concentrations, but there are quite a lot of other supporting information that we would like to also include in this service. And during this whole project, we have indeed been developing a newer version. So this is kind of a comparison on what are these improvements that we have been introducing in this latest version. So in short, we are modeling a wider range of different pollutant species. Then we are also using a higher resolution inner area around the Helsinki center, and we are modeling a longer time span so that the forecasting period can be significantly longer than in this version 1. Then the most important thing here is that we are utilizing Amazon cloud services to archive the data, and we are keeping a 2-week rolling archive there for now. And there are also plans to make this more of a permanent archive so that we can have perhaps 1 or 2 years there available. And one important thing to note is that these data sets available in our Amazon cloud, they are quite compact, so they are much more user-friendly if anybody is interested in archiving and having a longer time series of those end-user data sets. And one important thing to note is that this is under development, and of course you are able to access this data even today, and we of course appreciate the feedback of using this early access so that we can improve it early on. So here are the details how you can access these Amazon data for the HOPE project. So this is a public Amazon S3 data repository. And to make it somewhat easier to access, we are also developing this kind of a service so that one could simply define the area and time span for which you would like to have the data for in a simple way, and there would be this service for data downloads. Right. And of course, I should mention that there are already people utilizing this data access. But the next presentation will actually talk about this GreenPath application, so I will move on. Okay, and this is just an example of what the data actually look like if you would tap into this Amazon storage. So perhaps I will leave this as an additional detail for anybody interested, but the main topic here is that in this Amazon cloud you can find these kind of hourly packages of data as zip files, and within those zip files you have a collection of gridded data sets. So these are netcdf files, which are they are used to they are standardized in a way that you can, for example, use a program like Panoply, which I have used in this example, to open those data sets, and then you can browse the content and also visualize them right away. And then there's also some statistics relating to the measurement data that the model is using. And one of our ideas for the future is that we are also giving out these measurements that were used in the modeling and also sensor data in Helsinki, and we will add quite a bit of new metadata to those measurements so that they can become more usable and meaningful. What we have seen in our past experiences, that once you attach all kinds of information to these measurements, for example, the underlying meteorology and all those model predictions and things like that, you can really start to understand the air quality better once you start collecting the data for over several months period of time, and then you can do some more sophisticated statistical analysis. So in this case, in this example here, we have been utilizing this measurement data for a coarse particle sensor, and for example, we can see how the air quality in this location, in this sensor location, behaves as a function of a number of meteorological factors. Okay, so this is the final slide here, just to kind of outline our idea on this new type of modeling output. So not just giving out this model pollutant concentration, but also to deliver all kinds of relevant data sets that we can throw in there. One thing that I didn't say much about are these remote sensing data. So basically, one of the information sources is this daily snapshots of a satellite that measures the total column concentrations, and we have seen that you can do quite nice things with this new kind of information, and even these data sets are available on those archived packages. Okay, thank you. That's all.
All right, thank you, Lasse. there seems to be, I have to say, there seems to be a bit of an issue with the screen ratio. Your slides were very large for the screen, but we will share the slides afterwards. Thanks for the interesting presentation. A lot of data in there.
All right.
Yeah, you had a very large slide somehow. But anyway.
Oh, so you weren't able to see my presentation, basically.
They had a portion of it. But we heard you loud and clear. Hey, but we'll share the slides. And
right. Yes, I have this 4K monitor. That might be the issue.
I think that's probably the key here. So, but anyway, we move on. Thank you, Lasse. And now it's in the program. It's time for Miss Age Bohm from University of Helsinki, Digital Geography Lab. So welcome. The floor is yours. I turn this off. Put this on. There you go.
Yeah. Thank you, Jussi. And thank you all previous presenters from today and the forthcoming presenters. Very interesting to hear you all. Good morning from my behalf. I'm Age Bohm, working as a postdoctoral researcher at the University of Helsinki, namely at the Digital Geography Lab, which is a multidisciplinary research group led by Professor Tuuli Toivonen. And we have a small subgroup there working on the Green Path routing tool. And just to highlight, our main person here would be Joose Helle, the software developer, who is then the brain behind the Green Path technical development. Digital Geography Lab, as said, is a multidisciplinary research group whose main research themes are related to mobility and accessibility issues, but also nature conservation and the role of green areas in our everyday life. We work with big data sets, and very often big mobile data sets, and this is also the underlying motivation when developing the Green Paths routing tool. We know that when people move through urban fabric in the daily activities, or related to the daily activities, they are exposed to a number of environments that may have both beneficial as well as harmful effects on their health and well-being. Air pollution, the core theme of HOPE project, is the most visible one and also the most talked one, which has severe health effects. But there are also other exposures, such as noise exposure, but why not beneficial exposures, amenities, environmental amenities such as greenery or blue areas that gives actually a good feeling during the daily travel. And we know that when cities aim towards fair, sustainable, livable and healthy cities, they also need to do something about their urban planning and transportation infrastructure so that people would choose actually low carbon active travel modes. And if the main routes are very busy, very dense and have heavy traffic, there is a lot of noise annoyance and a lot of air pollution, then people would maybe like to choose other alternative routes that have less pollution and that are more pleasant. So there are very often alternatives to heavily polluted urban routes. So Green Path routing tool aims to find those routes which are less polluted and which are more pleasant and which favor active traveling, meaning cycling and walking. So the routing tool is an open source software or browser-based application developed at the Digital Geography Lab under the premises of HOPE project. And it's aimed for finding then cycling and walking routes which have either less air pollution or less noise pollution. And already in advance we are working also with greenery exposure, so to find routes that have more street level greenery than maybe the shortest routes have right now. How the tool is working is the user needs to define the trip origin and the trip destination, choose either walking or cycling routes, choose either air or noise pollution, and click on Find Routes. And the tool returns the user a set of routes, starting from the shortest to less polluted ones. So the user can choose which routes he or she wants to take, which are more convenient, more attractive, more time-wise more better, which they like more. So the tool brings forward health and well-being benefits through enabling exposure reduction, favoring physical activity and travel satisfaction, but it also enables exposure analysis at different scales. And with this routing concept, we are actually working at exposure assessment on population level to understand how different population groups are exposed to different travel environmental qualities during their daily travel and how this can be reduced. So the general workflow of the data is that we lean on external environmental data. Lasse Johansson just explained you the concept of an infusion model, the air quality model, and we are using indeed the 2.0 version of it, which is the newest version of Enfuser air quality model. And we use the air quality index, which is a composite indicator or index consisting of different air quality pollutants. And the resolution of this data that we use is 13 meters. At the same time, we also use noise modeling data, which is provided by the municipalities in the Helsinki capital region, and there the resolution is 4 meters. And as said, in the future, we are also going to show the street level greenery information. And from the Street and Path Network, we utilize open source OpenStreetMap data, which is a collaborative project, and we combine then the environmental data from one part and the travel data from the other part, and we run the routing analysis by applying a set of sensitivity coefficients that then enable us to find better and better and better routes in addition to the shortest ones. And the user interface communicates with the server application via a public routing API, which is then also available to anyone else. So to wrap it up, the GreenPath routing tool is accessible via a mobile-friendly browser interface in 3 language packages, Finnish, Swedish and English, that everyone can use in the mobile phone as well as at desktop computers. For developers, it is accessible via GitHub code repositories. There are codes both for the server side, for the routing application, for the API, as well as for the user interface. And we also welcome volunteer developers to join our team and to develop this open source concept further on. And if you're interested in the routing results, then there is this public API where you have to define the travel mode, the exposure type, the origin and the destination, and the API returns you a set of paths or a set of routes with different characteristics. There are very many characteristics, and you may all see the details from the link shared here, and that will be shared with you also via email. And if this API is going to be used in some other development in the future, it might be worth to discuss the options of setting up an alternative API just to reduce the traffic load. That is also because the API is also used via the public interface of the GreenPath routing tool itself. So there might be an alternative address then for these kind of other developments to avoid overloads. And now for the final part of my presentation, I would like to show you the video of the GreenPath routing tool, and I need to change the screen here. Thank you for your attention so far, and I hope you also enjoy the video we have made about the GreenPath routing tool. Here you go.
Jokaisella matkallamme aistimme ympäristöämme monin tavoin. Hengitämme ilmaa, kuuntelemme ääniä ja katsomme maisemia. Ympäristön laatu vaikuttaa oleellisesti matkakokemukseemme, etenkin kävellessä ja pyöräillessä. Päivittäiset matkat ovat monelle kuormittavia ja stressaavia. Näin ei kuitenkaan tarvitse olla, mikäli painotamme reittivalinnoissamme ympäristön ominaisuuksia. Green Paths -reittiopas auttaa sinua löytämään miellyttävämpiä ja terveellisempiä reittejä.
With our research team, we aim to understand how people are exposed to the surrounding environment during their daily travel. As a proof of concept, we have developed a journey planner that takes into consideration the quality of travel environment. We demonstrate that it is often possible to find routes with less air and noise pollution, but without a significant increase in travel time.
Uusi GreenPaths-reittiopas hyödyntää reaaliaikaista ilmanlaatudataa ja keskiarvoistettua meludataa, jota on saatavilla pääkaupunkiseudulta. Sovellus on kehitetty avoimena lähdekoodina, minkä toivomme kannustavan myös muita toimijoita huomioimaan ympäristön laadun reittioppaissaan.
Valitse kartalta lähtöpisteesi ja määränpääsi, tai anna työkalun tunnistaa nykyinen sijaintisi. Onko sinulle tärkeämpää ilmanlaatu vai liikennemelu? Voit valita kumman tahansa. Näet myös, kuinka paljon matka-ajastasi vietät erilaisilla melu- tai ilmanlaatuvyöhykkeillä. Valitse reittisi ja nauti matkastasi.
Well, thank you.
Thank you. Wait a minute. So we could have a bit of do we have any questions from the studio, so to say? You mentioned you're going to be introducing the greenery data as well. So that comes from the open data, the OpenStreetMap.
No, the greenery data does not come from the OpenStreetMap. The OpenStreetMap is for street and path network, like the transportation network, but it comes from two sources. One is land cover, which is approachable via or produced by remote sensing information, but the other one is street images, Google Street View images.
Oh yes. Yeah.
Yes, so we combine these two data sets because the Street View images are not available from all paths or all streets in this capital region, so we need to combine these two data sets.
Right.
But the principle is that we want to show how much greenery is on the human site level in the real environment that the human then senses, not only from satellite imagery.
Yeah. Excellent. And then when do you expect to have that functionality running, if I may ask?
Yes, so it's not running before next year.
Yeah.
So the development takes a bit of time.
For sure.
But it will be there before the whole project ends.
Yeah, excellent. Great. Thank you.
Thank you.
Yeah. And the GreenPaths application, it has daily users. I don't remember how many, but it's basically it's effectively in use, and the development continues. So it's a nice. Thank you, Agus. Nice example of very practical application of what's been done with our data so far. So if we go back to the program for a bit. All right, so we're moving on at a nice pace, so put it this way, very quickly, yeah. So the next part of the webinar is that we have 3 presentations from 3 companies using some of the data produced by the project. And first one of those, we have Mr. Mattias Andersson, who is in studio in person. And he's going to be talking about the artificial intelligence use. The title here might be not the current one, so let's take his slides in here. So AI in urban air quality analysis. So Mattias, please, the stage and the floor is yours.
Yeah, thank you. I just noted that apparently the fonts changed when I sent email, but
It looks a bit different maybe.
yeah, well, if you all can read this, then I guess it's fine.
That's good. Yeah, but now you have some time.
I have my 10 minutes to use.
Yeah, you do.
Okay, thanks. My name is Mattias Andersson, and I'm here to talk about how Advian is trying to use artificial intelligence and machine learning in analyzing, explaining, and communicating air quality issues or urban air quality issues, specifically in the Helsinki region for now. So at the basis of our experiment that we are doing with UI Hope is a machine learning model that is built to model and monitor how urban air quality changes between locations and in time in the Helsinki, and to try and find the different interactions and quantify different features and background variables that affect urban air quality, and in the end also communicate these to to the residents of Helsinki and users of our information that we are producing. As of now, everything is based on open source data, so we have no limitations on what we are using. Everything is very accessible, and I will come back to that in the next slide. And the target of our algorithm we are using is not only to predict the air quality model at a certain place and time, but also in estimating and as I mentioned, quantifying the interactions between the different background features that are there and communicating this information, and thereby trying to explain how local and temporal variables affect the air quality at spot X at this time and why. So why is my air quality bad or good and why not, for instance. And then obviously not only leave this running in a black box somewhere, but to try to convey and communicate this understanding with users of whatever application we will host the information on. So in the end, we want to raise more awareness about what affects urban air quality. What are the features that you have to take into account as maybe a user of green paths or just an interested citizen of the city. So more why, not maybe what or how much. As to our data sources, we are still going at a pretty lightweight framework with this thing, but obviously we've done some background reading and to identify the most important features and domains from where we need data, and of course taking into account the accessibility and open nature of whatever we are using. But in short, we are using a lot of FMI data with a small head nod to Lasse Johansson listening. So both air quality measurements from FMI's APIs, from where we get both some background features such as SO2, NO2, ozone concentrations, and a target variable, whichever we want to predict. First of all, particulate matters, this 2.5 PMs. Then we are also using FMI data on weather. As probably most of the people listening will know, air quality is affected to a very specific extent by the wind and the humidity, air pressure, and so on. So this has to be taken into account at an hourly basis for now. We also ingest road traffic data from Digitraffic's LAM sensors. So we get hourly data on traffic amounts at the big roads around Helsinki, also segmented into vehicle classes, how many personal cars, how many buses, how many trucks, at which point during an hour we have moving. Remote sensing's been mentioned already quite a few times. This is also something that we are using in our model to measure the amount of vegetation, which Age was talking about already, around the different spots. We do it with Landsat data, just a very raw approximation of the vegetation index around each measuring point every 2 weeks, or I guess it's 2 weeks how often the NASA data is measured. And just as a note that there's obviously way more data sources we could be using. The Enfusion model has a lot of interesting topics, so I'm going to look through those slides pretty densely. Building intensity around points, obviously there was mentions of these traffic canyons and how those might affect. It's as of now not yet in the model because there's very little temporal variance in building density, so it's not as such maybe an explaining factor, but something that we'd like to bring in once we find a good way to do so. Very shortly on the model architecture, won't go into technicalities, mostly because I'm not the one responsible for the technicalities, but it is a machine learning neural network model, and we have a very simple workflow chart here on what it's based on. It's based on obviously all the data I've just been talking about, and a list of functions, weights, measuring options that are then trying to understand the actual endpoint, the air quality in point and time, all the time also recording those different weights, those different importance levels of all the features, so we can present them onwards. So maybe at the left side you will find where this is different from many other machine learning models. We are not only trying to predict something and then visualize predictions, but we also want to measure to what extent each of these features affect the air quality. So as concluding remarks, maybe is that we want to find as wide as possible dissemination from the results we find in this experiment, so that whatever wisdom we find regarding urban air quality, we can also tell everyone else, citizens using, everyone affected by this project. And for this, we are building a lightweight, probably web browser-based interface for users, based as closely as possible on the citizen needs that have been identified, that will visualize the relationship between different factors and the air quality at a space and time. So our vision is to have a interface where you can have a drop-down box. For instance, I want to know about the air quality in Jätkäsaari or Pakila or Mannerheimintie, maybe 28th of October or some other point in time. What is it that measures? And then we'll have an interface that visualizes bar chart these. Maybe it's wind, maybe it's weather, maybe it's a lot of traffic, but an interface that tells you how much which features affect the air quality. So, for instance, we can have a sentence such as the air quality in Kallio is really good at this time because it's Saturday, it's not a lot of traffic, it's very windy, the wind blows from the north, so all these particles from the big ships aren't blowing this way, and so on and so on. But this is a vision, and this is something we will have at some level online by the end of November. Unfortunately, I have nothing to show today because the experiment is still at its most intense part going on right now. In short, we want to bring this, maybe a bit of the artificial intelligence, machine learning buzzwords out of the black box and try to explain a bit more how it works and do it by the example of urban air quality. And of course, we are grateful to have the opportunity to do so. In the longer run, our vision for this experiment, what could be done is that, of course, this is a short period implementation and we have clear targets which we want to tackle during this fall, but it will not be perfect by the end of it. So we are hoping to have opportunities for further development. Everything is done open source, so why not also community development? We are visioning a pretty similar structure as the Green Patch to have a GitLab repository, also for so-called outsiders to use. As all the data we are using here is also available for at least all of Finland to some level, it would be a pretty natural next step to expand this also outside of Helsinki. Why not Tampere, Turku, as such, anywhere where we have measuring points for such the data we are using, this model can be expanded. More data sources is always better data science, so to speak. So we are looking all the time. I mentioned these building densities already. A lot of the things from the end-user models Lasse was talking will probably come in handy. There were some new things we are still not using. And also, as for some of these variables we are using, there are available predictions for the future, weather and so on. So in the end, it would obviously be great if we'd have enough of historical data to expand our model to tell you about the air quality tomorrow also. But that is maybe a bit of a stretch today, but hopefully we'll get there at some point. I have not used enough time, so to speak. Maybe shortly from who we are. We are Advian. We are a young, growing, refined analytics company. A lot of geographers, a lot of GIS people based in Otaniemi. We do a lot of artificial intelligence, machine learning based on a lot of location information and satellite, also video data, and so on. So that's my short introduction on us. And I am a data analyst 1 year back at Advian with a background in Kumpula, quite a few years back, but anyway. Thank you. Any questions?
Thank you. So do we have, come up here, do you have any questions from the studio, first of all? If not, then I just need to comment that, because you were successful in our innovation competition. I was part of the jury, and the point was that when you pitched your idea, your concept, we were very much intrigued. What is it? And it was a kind of thing that the jury thought that this is kind of a card that we cannot left unwatched. We need to see what is it about and what you're offering, because it's kind of there are open questions there, obviously. And then the way of how you are doing what you're doing, analysis, and seems to be everyone's like, okay, we need to take this and see what they come up with. So it's super interesting. So thank you,
and we are of course grateful to have this chance. So
great.
It wouldn't be done without you. So
nice having you here, and thanks for the presentation as well.
Nice.
All right. So maybe thank you.
Thanks.
We move on. Come here, and there doesn't seem to be any questions from the online audience. I need to check it still, but the next one, if I put this on, all right. So now we go back to our distant speakers, put it that way, and the next one would be Jaakko Lehto from Gispo Oy. So Jaakko, I see you there. So please.
Yes.
There you go.
I will get my things ready.
Yeah.
Just a moment.
Yeah, you may take the screen, and I will switch off the microphone from this side so you don't get feedback.
Okay, good. Yes. Can you see my slides now?
I can see a slide. We can hear you. Just a moment.
Good.
It's all good. So,
nice.
So
okay.
Please go ahead.
Thanks. Hello for everyone. My name is Jaakko Lehto, and I work as a geographical information systems specialist at Gispo. And today I'm talking about our contribution to this Hope Innovation competition. I'm talking about this project FMI to QGIS tool. And but first I thought that I might give some background and motivation about what we are doing and why we are doing this project. So a little bit first about us, about Gispo. So it's founded in 2012. We have currently 11 employees in offices in Helsinki and Turku, where I'm currently at. And we basically just help our customers to solve their geospatial problems with open source tools. And this project is also really closely related, connected to that. So yeah, this just sums it up. And and this also is what we do. We can do some cool things with open source tools. This is some of our tools, which mainly I will be talking about QGIS, because the project is related to that. So to give some background in that first, I mean, it's of course popular software, but in case some of you don't know or haven't been using it, it is the most popular open source GIS desktop software, and widely used, and has a lot of nice user-friendly tools and powerful tools, and active community with tens of thousands of users, and both in many private companies as well as organizations and public institutes and so on. So and how it is related to this project is that the project name tells it quite clearly that we are using FMI data and trying to use it in QGIS. So the premise of this is that, as we have been seeing today as well, that Finnish Meteorological Institution is the primary data source provider for example, for end user and air quality data in Finland. But the sort of problem is that currently it's not so easy to use it in QGIS as it could be. So for example, the WFS interface it is not fully supported, like the complex feature structures and so on. And there are, of course, a lot of parameters and so on. So the aim of the project is just simply is quite. I mean, compared to some of these other applications we've seen today here, it's quite basic and sort of fundamental that we want to, because there is active community also in Finland and abroad using QGIS. So we want to make the FMI data and air quality data in particular more widely accessible and more easy to use. So in that way, of course, we hope that when it's more easily accessible, more people will use it, and more it will help to visualize it and analyze the data, and more applications will come as a result of that. Okay. So just to give you some idea, just example picture we've been using to study the Enfuser data in QGIS, and once this sort of data importing is easy, then you, as I said, you can combine it with other data, and you use all the tools that QGIS brings to it, and make some analysis and so on. And how we do it? So just a few words about QGIS plugins, what they are, because that's basically what the tool is that we are developing. So it's sort of easy way to extend the QGIS core capabilities. So those are little tools that can be programmed with Python, and then I mean, if you have just some special use case that is not, you don't find the tool in QGIS install ready, so you can quite easily develop those, and then the sort of importing it or delivering it to other users is really easy. There is this central plugin repository, which contains over 1,000 plugins, and that's the way we are going to be releasing this plugin as well. So we have some prior experience in developing some interesting plugins. For example, this globe builder that there's this example picture as well is the sort of 3D globe Google Earth kind of plugin that we recently developed, which has been quite popular. So now it can be used everywhere. And also there are these, for example, National Land Survey data loader, this Kaava plugin that is land planning, helping in that, and also some other data exporters. So they have some similarities with this plugin that we are currently developing. So the idea is that we would be developing a plugin, a tool that would make downloading and adding the FMI data more simple and easy, just easy and simple to use interface that can be, as I said, that can be, in a couple of months' time, can be just, you can go to this plugin repository, which is kind of a Play Store or more familiar in mobile world, and just push one button and it will install this tool, and then you have a easy to use interface. You can choose what parameters to use and from what time you want the data and so on. And so of course this is very much work in progress. So you cannot find the plugin yet, but quite soon it should be ready. So this is just an example test picture as well. So yeah, and some features that we are putting in this initial tool. So just one part would be to fetch this enfuser data, and yeah, in this netcdf format, and another part would be this using these stored queries in WFS interface, so that you would have a easy to use interface downloading those as well. And of course, there are some challenges. I said that the data, the amount of data can be quite big. So, for example, although this netcdf format is supported by QGIS, of course, it's not that widely used in GIS, maybe more in sciences and so on. So there are, of course, some those things that have to be taken into account. Yes, but we will be, of course, as I said, we are open source company. We will be developing this plugin as an open source, and there's this GitHub repository for that. And we should have, so as I said, this is work very much in progress, but we should have a, sort of minimum viable product for testing somewhere in November and December. Well, yeah, let's say late November, early December. And yeah, that's pretty much all that I had in mind about that. Are there any questions?
So, just wait a minute. So thank you.
Yep.
Do we have any questions in the studio, first of all? There is one, please.
Just a comment from the previous speaker that this is a very welcome tool, because I've been swearing about the same issues quite a lot, so please hurry.
Exactly. And now you also get thumbs up from the other person in the back of the studio. And I have to say that also, in our competition, the jury also thought the exact same idea, that this is so helpful, a usable tool, which has been missing, obviously. So just to get, making it easier to use the data, so that's very welcome.
Yeah. Yes, it's sort of a very fundamental or basic, let's say basic research or development. So it's, yeah. And of course, it can be further developed from that. But yes.
Exactly, yeah. Our distant speakers who are there in the teams, does any of you have a question, actually? You might speak up now if you have, just occurred to me. If not, then we thank you.
Yep.
Okay, there's a question online. Wait just a moment.
Okay, yep.
Let me just seek it out. Okay, so the question here is, can this data be used to create a city-level emissions inventory?
Well, as I said, it can be further developed, but it's like as such, it is basically at this stage it is just helping to get the data to QGIS, and then if you want to, I don't know. Of course, you can then use all the tools that you have there, and if you have, not directly, but I would assume that it would be one tool in that direction. Does the asker have any more detail what he or she would need in that? It doesn't do it automatically. It is not a feature of this initial tool, at least.
Yeah. There was no further details, but
Okay.
but basically, let's just assume that it's something that could be further developed.
Yeah.
It's a kind of idea to put on the bucket list kind of thing.
Yeah.
Great.
Yeah.
Excellent. Hey, thank you for your presentation, Jaakko, and And we move on, and then the next one on the list would be Jarkko Sireni from XD Visuals. So, Jarkko, do we have you? I mean, I see you there, so please, floor is yours.
Yes, hello, thank you.
I switch off this.
And I will share my screen. So I hope you see my presentation.
Yes, we hear and we see you well,
So
please go ahead.
Yes, thank you. So what we are going to do in our company, XD Visuals, that we are focusing on the digital twin technology, and digital twin as a term means a kind of a digital copy of the reality, so that we can make different kind of analysis, optimization and simulations digitally before we do any actual implementation. And our focus has been on city planning, design and construction of urban areas like buildings, city areas, roads, highways, traffic and that kind of things. And as a motivation, as a background, we have a very good digital twin of the existing situation in Helsinki. Helsinki has made this Helsinki 3D++ city model, which is an accurate 3D information model of the existing city. And Helsinki is already using this digital twin in different kind of city planning purposes, for example, in area planning, traffic planning, energy, construction, mobility, and that kind of things. And the idea of this using digital twin in planning phase is that you can reduce cost, reduce time, make more sustainable and functional cities by digitally simulating everything before the actual construction. And the biggest motivation here is the city planning phase. If we think about the timeline of building a new city, in city planning phase, it's the most early phase where you make the biggest and long-lasting decisions about what is going to be built. And the more you go longer in the timeline, the less you have possibilities of making changes. So that's why we want to bring the air quality management or air quality planning into the city planning phase, because then you can have most influence in the future of the city, also in air quality. It can be other things also, like noise and traffic and everything that you decide in this city planning phase. This kind of similar solution have been made in the world, like the weather and electromagnetic fields. Helsinki has made a lot of work with the solar energy and energy usage of the city, wind simulation, flood simulation, groundwater simulation, but I haven't seen much similar with air quality. And this was the kind of the idea of our project. And we also have a platform that we have developed. We already have a platform that can integrate this digital twin of the city with the future city plans and design and construction data. So we can import different kind of project data and create a kind of four-dimensional model of the future of the city. And into this platform, we will then bring the air quality tools and visualization, so that air quality will be automatically part of these processes. So we have different kind of processes. So the green boxes are what we already have in the box, and in this project we add air quality as one additional data layer. And because it is added into this digital twin platform, it will automatically go into city planning or design and construction processes. So we kind of bring it automatic to these processes without these people even knowing that, okay, there's air quality information. Nice. Another thing is that we do two different aspects. One aspect is the information about air quality. We will make visualization and import of these FMI and sensor data, which are kind of scientific data about air quality. We also make application to measure how people feel air quality, which is a different kind of data. and we combine that into the normal collaboration process that every new construction project has this collaboration and feedback process already, that we ask feedback from the citizens about the new designs, and into that existing process we integrate also this air quality feedback collection. And on the other side, then when we have information about the air quality, we need tools that city planners can take air quality into the planning process, so that they can maybe document the sources of bad air quality, may plan improvements of making better air quality in the city planning phase. And we already have all the different user interfaces, everything working on web. We have AR and VR user interfaces, so that we can visualize this design and air quality information in many. So this is the kind of a mock-up. This is not a real final version of this, but what it's going to be look like. So what we have here is a 3D model of the city coming directly from the Helsinki city server, which city maintains and updates the city model. Then we have the FMI air quality data from the VMS data as one data layer. We also can import the sensor, IoT sensor data. These might be different kind of visualization in the final system, and these smileys are then the feedback from the people in different locations, how they feel about the air quality. So this is the kind of visualization part. Then we have the feedback part. So this is one area plan design in very early phase in Kalasatama. This is how the city communicates the area plans to the citizens, and citizens can give feedback about the design and other aspects. And into this existing process, we integrate the air quality collection, so that if this is a separate independent tool, probably the people wouldn't go and use it, but people are interested about the future of the city, so they want to see all the city plans, and in that phase, it's more probable that they will also give the information about the air quality, how they feel it. And then we have tools for designing the air quality visualization, and I have a small demo here how it's looking. So we are using this kind of Cesium-based platform for visualization. What we have here is the Helsinki city model. It's streaming from Helsinki city server. We have, for example, here is an area plan model of the Kalasatama design. I can turn off the air quality layer so you can see the air quality or area plan designs. Then we can have some other kind of designs like these new Triconi towers here in Pasila. So this is the typical design data that the projects are working, and the area planning process, they are working in this kind of area block design phase, like new buildings or new parks or new daycare center or new office, and using these kind of sketch tools, the city planners can then manage the air quality. For example, they can document that okay, there is a construction site that will produce pollution to the surroundings. This industrial area will be removed, and it will improve the air quality in this location, and this way take air quality into the city planning process. And of course then we have this data layer from FMI, and also some like sensor data from different kind of sensors. So that is our kind of solution, and we think we have a lot of benefits for this. First of all, the air quality in cities will improve when the city planners take air quality into account in city planning process. And another thing is that basic understanding about air quality will improve, because we can see the air quality statistics together with the real world surroundings and maybe with other information. If we add, for example, traffic information or construction project information, we can see connections between different sources of air quality and then start to understand and improve it better in city planning phase. And the citizens will have more influence in first of all, the future city plans, but also how to improve the air quality, so that they can say that I feel this is very bad air quality here, so the city planners can then plan some improvements into that. And of course, because we have this VR, AR technologies, it will enhance new technology usage. I think this opens global business opportunities also for digital twins and also collaboration opportunities. I see previous presentations instantly that we have a kind of connection right away that we could connect our different solutions together, for example, and make a good solution for exporting that into global markets. Especially, I think, for example, the AI connected to city planning is very interesting area, and also the Google's open source solutions. So the idea is that after this project, this can be taken into use in any project in Helsinki, and of course, if we get data from other cities that was mentioned earlier today, like Tampere. Tampere has similar digital twin already available, and we can utilize this also in Tampere and other cities that have enough data, and this can be applied anywhere. We already have a global basic data about every city in the world. For example, here is an example of New York. We have all the buildings and the basic terrain model of the New York available as open data, and it's already integrated in our system. So this can be very easily applied to any city in the world, and also I see opportunities with collaboration with the sensor manufacturers to deliver this kind of digital twin technology as part of the sensors when they deliver it globally in different cities. And I think this is pretty innovation I haven't seen before, integration with air quality with a 3D or 4D digital twin of the city that also has the city plans integrated, and I haven't seen air quality so much integrated into city planning project, and what we have already discussed with the Helsinki city planners that it is in the city planning phase, but not in this kind of intensity that we push in this project to bring it more intensively into the city planning. And I think this will be first tool that visualizes air quality information in 4D georeferenced on-site with AR, with mobile devices on cloud. So I haven't seen this kind of tool earlier anywhere. Maybe there is. And probably this is the first application that can measure how people feel air quality in the whole city scale. So this is working everywhere in Helsinki. So it's not limited into any pilot area. So we can utilize in the whole city scale. Thank you. Any questions?
Okay, thank you for your presentation. And we actually have some questions on our YouTube chat. So let me go through this. The first question is how, in your tool in the digital twin, is the construction site data it's updated? It's up to date. Yes.
Yes. So if you have a construction project, you can import any kind of construction data. So we support all the BIM formats for building and infrastructure construction. We support drone photogrammetry models. We support laser scan point clouds. We can import almost any kind of data. So that when the project uses this digital twin platform, they usually have always up-to-date data on the site.
Okay.
So yes.
Yeah. And there was a question also whether, what kind of compounds are there, in that data, but that's maybe not. It's about the data that you use, but so maybe the question is more targeted to FMI and the people who are actually monitoring. But then there's other question like, does the tool, your tool here, does the tool use IoT sensors as feedback mechanism to measure the accuracy of your projections?
That's maybe a good idea to think about. Yes, we haven't thought that far in this project. We were thinking only bringing the IoT data visible to the city planners, so they can see maybe the current situation, but also if it's available, the historical situation, because I think the air quality is something that varies during the different time of day.
Yes.
In the morning it can be very clear, but in the afternoon it will get worse, and also maybe the seasonal changes also vary. So I think this kind of 4D time dimension in this is very important. Also, air quality should be maybe 3D also in elevation, so that we would have air quality in different elevations.
Yeah, that would be definitely an interesting, element to the visualization, especially. And I believe you're right what you said, that there's, for the citizens there's a lot of interest in this kind of way of visualizing the city and the way it's going to develop. So it's definitely interesting from that perspective as well. People want to see how it is going to look and all these kind of things. Let me see if on the studio, do we have any questions from the studio people in here? No, I see. There's also other question here for you. Can the tool be used to measure building efficiency, and referring to the efficiency of building heating systems and such? And we know that there is the city of Helsinki, the kind of the heat map, building heat map thing, right?
Yeah, Helsinki has a separate application based on the city model that has energy data about every building, what is the heating system, how much energy they use, and they even have data for solar energy potential and these kind of applications. And those are available in Helsinki city web pages. If you just search Helsinki 3D, you will find the links to these databases. And yes, in the future, also that data should be possible to import into this digital twin.
Great. Yeah, it's interesting as well, and for many reasons. But great. Hey, Jaakko, thank you. And it looks very impressive what you're doing here. So thank you for the presentation. And I guess we move on. And it means that, just let me close this. The last but not the least speaker today. Oh, hey, one thing I need to point out. We had here present 3 companies, but that's not all. We actually, in our Hope Innovation Competition's first round, we actually had 6 companies. So I need to mention them at least by name. They were not selected here to give presentations because their approach is a bit different. But we also had Pegasus Oy, who does air quality monitors. We have Laatukilpi Oy, who is also working with the kind of monitor technology more, also with data a little bit. And then we have PlaySign, who are doing kind of bit different thing of activating the citizens by using the air quality data. But they were not here today because the theme is a bit different. But let's just mention them as well. And then the last presentation of the day is going to be Mr. Pekka Niskasaari from Forum Helsinki. And as I said, he's going to be introducing the second round of the Hope Innovation Competition. And yeah, let's give floor to Pekka, and then if you have questions on any of those. So Pekka, please, floor is yours, our screen is yours. And we see you.
Thank you.
And we hear you.
Yes. Okay. Thank you for a possibility to be in this event. And also thank you for all the colleagues in the other parts of the project and the organizations. Excellent presentations. Nice progress on all divisions on the, for example, the SMEs experimenting with the air quality data. Happy to hear and really impressed about the things you're doing for this common purpose. But okay, let's go for the topic. So like mentioned, it's innovation competition round 2, and it's a little bit different approach. So we will go for innovations, for interventions, and I will briefly explain the thing, and later on the full data and the explanation of the competition will be public. Yes, just a reminder what has happened in Hope project overall. is that we have these core activities, as you might remember, that we are crowdsourcing sensors, like Andrew explained there earlier, that in Vallila, Pakila and Jätkäsaari region we have these mobile sensors deployed with the citizens, having this field sensoring with low-cost devices. Secondly, we have an existing network in Helsinki for excellent high-level professional sensors provided by Vaisala and partners and operated by Helsinki Regional Environmental Office, HSY. In our project, we of course try to kind of accelerate the data package or data sources to be available for companies. Like Lasse from FMI explained that the air quality index 2.x version is coming. There are new dimensions and new use for that. Of course, we have this prediction model from FMI and future model, and then, like Andrew explained, the MegaSense data storage for these mobile sensors. Now, on the last year of the whole project, we will more focus on the citizen participation activities, which are including the personal activity reporting that might lead a bonuses. So more you move, more you make the better air quality, more you have incentives coming from the city sites. Of course, you have this voting opportunity, which will give a promotion for using different interventions per region to help the air quality to get even better. Finally, we have this innovations division, which the first touch was the innovation competition during the summer and early autumn time. So we call that as a competition number 1, and like you heard, there has been 6 final winners, and the experiments are ongoing. So I will now introduce you more about the details on the innovations for interventions part of the competition, which is the second big innovation competition involving SMEs. First of all, a couple of words about what are these interventions for districts. Basically, these are actions to improve the air quality in different formats. And the black ones in the text are the core activities, how to improve the air quality in these areas. Like you might see the street washing procedure, temporary road asphalting or surfacing procedure, providing e-cargo bikes, providing pre-washed sand for housing companies in order to prevent difficulties with icy roads, of course, speed displays for early warning for the drivers, car users to lower the speeds, providing mobile dashboard with real-time traffic and air quality information. Then, like in Finland, we have a big issue with the studded tires. In winter time, we have these tires which cause a lot of particle emissions, and of course, the detection of the tires might do some preventive or reactive actions to get the friction tires instead. And then on the personal level, if you as an individual, you might have doing some activities to promote or using less car, for example, then you might earn a city bike free of charge or get the travel card or discount for buying these friction tires. And then you have a direct channel to report air quality issues with your mobile app. And as a core functionality in these interventions is the hope.useless.fi web app, which is a personal application you use for reporting your own activities, and later on there's the voting possibility for these interventions. Of course, as add-on for these, you can contribute your own suggestion of a service or action per region, or you can contribute an idea of a personal action how to improve air quality. So meanwhile, you are collecting your own action, reporting, you are also voting for different interventions, but you can also contribute ideas via this application. So this is how we have selected these activities, is simply so that the harm compared to euros are the biggest ones, and these are the most easiest to implement in the districts, and that's the study we have done in the project. So okay, but let's go for the things what we want from SMEs. It's simply things that would make this air quality better in a digital way. Like we're not finding or willing to have services which are the similar like the interventions mentioned, like no street washing and that kind of services, instead digital solutions. You can apply hardware, software, mixture of services or whatever related to digital approach. It can be a website, it can be new type of data storage, hybrid, or any digital solution. The main purpose from your innovations is that we want to have something which will enhance the quality of life as in the perspective of citizens in terms of health. So taking consideration into air quality, and of course the interventions listed there. This should be something close to citizen benefits, and that's something we are willing to have. Your solution can be also an evaluation of intervention performances, the interventions mentioned in the previous slide. It can be also the one which activates or triggers some action or intervention. It can be a solution which eases a way to find intervention faults of misconfigurations. So if the interventions we're using are not properly adjusted, that can be also a purpose for this digital application. Find new paths and methods how to develop new air quality interventions or actions. And then finally, like mentioned, we're collecting some ideas from the citizens. They will be listed later on our websites. And of course, these will be also like a seeds or inputs that you can take into your use. Unfortunately, the time frame is so short that it might be so that the last bullet we will not probably get so many ideas from the citizens. Anyway, I pinpoint the first one is the thing that we want is to enhance the quality of life of citizens in terms of health and taking consideration the air quality. But as a SME viewpoint, do not propose something which is already done in wider scale. So we are not interested in that kind of things. Please be innovative. And data available, various of sources, listed here some. You remember the previous presentations. There were a lot of data sources, Venture with Air, GreenPath Toolkit, MegaSense data packages, FMI and Fuser. You can use them as to enhance your solution. And the interventions previously listed are not kind of fixed content. There might be some more, there might be a little bit less. What, how and when? Okay, key focus, like mentioned, maybe 4th or 5th times, digital solution connected to some way to air quality cities in city and air quality interventions. Competition is open for SMEs with valid EU business ID. So if you are a foundation or registered union, you are out of the competition. You have to have a suitable business ID number. Then national procurement rules applied, and like previously, we are not translating all the materials, just some core elements. So translations, if you're coming from elsewhere than Finland, you must provide the translations yourself. Experiments procured for 3 to 8 months time. We are not going to buy any assets, just services, and for that limited time. Intellectual property rights remains for the creator. We will not take them from you. You can use them in any format you like. Request for tenders will be open 31 days, and that will open early November. So pretty soon, published in Hilma websites, project website like ilmanlaatu.eu and Forum Virium website. Decisions will be made late this year or early next year. Experiments will be launched early next year. Evaluation criteria is 20 to 80 price to quality aspects, and quality details will be published in final request for tender document. And like said, in somewhere we will commit over 100,000 euros, but zero for the winners. And so far we haven't actually decided the final number of the winners, but that's the bucket of the money. So some important websites: ilmanlaatu.eu, project side. Company Forum Virium is in charge for this innovation competition part 2. So it's our shortlisted website, fvh.eo-hope. Sorry, there's a mistake in my email address, but it's forumvirium.fi, not Viriu. That will be changed. And then the easiest way to think is to get the newsletters ordered to your mail. And like I said, Hilma, a national procurement system announcement will be launched soon. Thank you. I'm open for questions, if any.
So thank you, Pekka. So I see no questions in the studio, and I need to check the online forum, to put it that way. I think there are no questions concerning this, but you had pretty informative presentation. So the data was there, the facts. So I suppose we just welcome all of the SMEs, the innovators to our competition once it opens. Keep an eye on our website and the Forum Virium website, obviously, and Hilma in all of these places mentioned. And you're free to contact us for any questions about this, obviously, once we get it open. Yeah, I guess we come to the end of the show, to put it that way. End of the seminar here. Nice having you. I saw that we had quite a good number of people following us during the seminar. And maybe I suppose we just say first thanks. Oh, we have a question here. Please.
How do the other people access the materials? Making the materials open?
Oh yes, the presentation slides, we're going to put them on our website in PDF form, I suppose, and considering also these saavutettavuus demands that we have nowadays. But anyway, yeah. And everyone who's registered will send an email out to you once we have the slides on the website. Inform you about that. Yeah. All right. But hey, so first thanks to the speakers in the studio, online, and then all for the audience. And looking forward to having you in our events again. Thank you. All right.
Thank you.